All right. Hey, Algebra 2. For this video, we are going to look at some linear models. So basically using linear relationships to write equations for some kind of more real-world situations. So we're trying to model a real-world situation with an equation. And so on page 30 and 31 here, we have some kind of notes that we'll talk through quickly and some examples, and then we'll actually do a couple problems here. So just like kind of looking at page 30 here, it walks us through some steps. So we have a kind of a decision to make. When we see a word problem, uh, we're, we're looking for ones that either give us two sets of data or one set and a rate of change. And so it sort of turns it into two different types of problems. If we get two pieces of data, that's going to count as two ordered pairs. And when we have that, we can use those 2 points. We write them as the points. We find the slope, write an equation. And here's a key thing that we're going to really focus on this time is making sure we put our variables in context. So instead of using x and y, we're going to use words to represent variables. So then step four is we use the equation to answer questions. Okay, so example quickly to sort of skim over here is one about Jacob starting a newspaper route, and it tells us that after 3 months he had 532 subscribers, and after 7 months he had 1681. Right, so that's two data sets. Right, and so if he continues this pattern, how many subscribers will he have in 1 year? Okay, or two pieces of data that we're given. And so that's where we're going to write our x, or our 2 points. 3 comma 350 532 and 7 comma 1681. Okay, and then you can look through the steps here of finding the slope, point slope form, writing the equation. Notice we're going to need a calculator. Okay, and then at the end, we change our variables to be, instead of x and y, subscribers and months. Okay, and what needs to go on these, and our printer doesn't print these for some reason, is this little hat symbol. We literally call it a hat. Okay, and so we're going to put that over subscribers every time, and what that means is predicted number of subscribers. Okay, because our model is meant to be a prediction. It's not like the real world's messy and not everything is a perfect straight line, right? And so this is a way to predict, but it's not necessarily going to be the exact right answer. Okay, it gives us a good educated guess in a way, if you want to put it into a kind of an older term that you might remember from middle school. Okay, so that's an example of two data points. If we look at page 31, here's an example of where we're given a rate of change and a data point. And so when you read this problem about Rachel trying to grow out a bad haircut, she found her hair grows about 3 inches every 2 months. Okay, there's a key word in there, every. That tells us this is a rate. 3 inches every 2 months. This is a rate. Okay, it's repeated over and over again. Her hair is now 8.5 inches long. That's a data point. Oops, that's not the highlighter. That's a data point. Now 8.5 inches long. So if this pattern continues, how long will her hair be by prom? Here we go. We could look at this. So we take the data point now. Well, that's like time equals 0 right now. So we would have 0 comma 8.5. And then if prom is in 7 months, we know that that is 7 months from now. So that would be 7 comma something. And then we need to find our slope. Well, we're given a rate of change of 3 inches every 2 months. So 3 over 2, we divide it out. That's 1.5 inches per month. Okay, and then we can use slope-intercept form. So I'd rather spend some time doing a couple problems with you guys. So let's flip to page 32. All right, got a problem here. Jeff making customized paper airplanes. And it costs him $36.50 to make 4 airplanes, and it costs him $44 to make 7 airplanes. Write a linear model that represents the situation and context. So what I notice is we don't have a rate, we don't have like dollars per airplane, but we do have 2 data points. That many dollars for 4 airplanes and that many dollars for 7 airplanes. Okay. Now, what's important to keep in mind is like what is going to be our x variable, what is going to be our y variable. And so it's sort of, I think like cause and effect. Does the dollar amount cause him to make 4 airplanes? Or is it that he makes 4 airplanes which causes a price of $36.50? And so the thing that causes, we call it the dependent variable. You've probably heard that phrase before, the dependent variable. So that 4 number, the number of airplanes is going to be x, the price is going to be y. Okay, with our independent. So my 2 data points are going to be 4, comma 36.50 and 7, comma 44. So what I want you to do, grab a calculator, and you can pause the video and try to find the slope here. Okay, so you should have gotten $2.50 per plane. You do the y minus y, x minus x, and you end up with 7.5 over 3, which is 2.5. And we know that dollars, the 44, the 36.50, that's dollars. Number of planes is on the bottom, so it's $2.50 per plane. So that's our slope, and we have points to use, so we can use point slope form. So I'm going to think about y minus y1 equals m times x minus x1, and I'm going to pick one of the points. I'll pick the one that doesn't have any decimals in it. Y minus 44 equals slope was 2.5 times x minus 7. Okay. And then I will put this into slope-intercept form. So we'll have y equals 2.5x. I'm just distributing the 2.5. So then I have to do that times 7. I get minus 17.5. But I'm adding 44 to that because I added 44 to both sides. So we get y equals 2.5x plus 26.5. And then we have to, the last thing you have to do is create, put words in for x and y. Okay, so I'm going to write this final answer here in green. And we're going to say y, we know that represents the total cost. So predicted cost with the little hat on it equals 2.5 times, and then I'm going to use x to be planes plus 26.5. So there's my model. Then we're going to use that in part B to predict how much it would cost Jeff to make an order of 24 planes if this pattern continues. So 24 planes, that's 24 planes. And so I'm going to predict by plugging in. So I'm going to do predicted cost equals 2.5 times 24, because I'm predicting 24 planes, plus 26.5. And if you type that in, you get 131.5. So we are going to write a little sentence. Predict 24 planes is predicted to cost $131.50. Okay, so we want to have a kind of summary of our answer there. And we need that word predicted, because that's a key part of what we're doing here is we're making predictions based on a model. Okay, I'm going to just have kind of go through too quickly here to set it up. So pause it if you want to try it on your own here. Tony is knitting sweaters. He's already knitted 5 and continues to knit 3 sweaters every 5 weeks. Already knitted 5, that's our starting amount. 3 sweaters every 5 weeks, that's our slope. So you'd use those to find your slope of 0.6 sweaters per week, 3 divided by 5. And then we have the beginning amount of a y-intercept, 0, 5. So then we'd plug this in to create our model to slope-intercept form. And then replace the x and the y with context words. And sweaters and weeks, and don't forget to put the predicted symbol there. And then we'll use that for part B. And when you do all that math, you end up with 15.8. Notice we have that predicted word there. The model predicts Tony will knit 15.8 sweaters. As long as you showed this work of and actually getting 15.8 as an answer here, I'd be okay if in your summary sentence you said approximately 16 sweaters, but I should see 15.8 in your work as this is what the model actually predicts. Here's the kind of more real world appropriate answer. All right, thank you for watching. Have a good day.